what we're doing in this unit is going to be the opposite of what we did in Unit 1. Unit 1, we took the sine of 30 degrees, and the sine of 30 degrees was equal to 1/2. So that would be an example of what we did. The sine of 30 degrees equals what? And we answered that. We looked at our unit circle. We went to 30 degrees. We looked at the y value, and it was equal to 1/2. Well, now we're going to do the opposite. We're going to take the inverse of 1/2, and we want to know what that is. Now, I will tell you that the directions are always going to tell you to answer in radians. So we go to where y equals 1/2, and we're going to do the opposite. So this is going to be not 30 degrees, but we'll change that to pi over 6. This statement right here is very, very important. You can only take the sine, cosine, tangent, secant, cosecant, cotangent of an angle, and that equals the ratio of the sides, your SOHCAHTOA, or the reciprocal. In this unit, we're going to take the inverse of a side, which is just a number, okay, a value. It's the ratio of the sides, and that's going to equal an angle. And the directions will tell you to write that angle in radians. So we're always writing our angle in radians. Yes?
Where did you get the pi over 6 for sine?
So instead of 30 degrees, I wrote pi over 6. So I just undid this. 30 degrees is the degree measure of pi over 6. So this could have been 30 degrees. Those are equal. Okay, it's just the radian versus the degree measure. But I just added to this. In this unit, we'll always ask you to write the angle in radians. So that's why I changed it to pi over 6. So this says sine of 30 degrees. This says the inverse sine. So let's think back to the last unit. Is there a difference when we graph y equals sine x versus y equals the inverse sine? Was there a difference between those graphs? Yeah, we just took the test yesterday, right? Hopefully we know that. Just took it yesterday. Y equals sine x looks like this. Y equals the inverse sine of x. Looks like that. Okay? So it's the opposite, okay? The sine of an angle is not the same as the inverse sine. This is the sine, this is the inverse sine. Remember, we've done sine, we've done inverse sine, we've done cosecant, the reciprocal, all three of those. So this was unit 1. I gave you the sine of 30, or let's do sine of pi over 6. That's maybe less confusing. 30 degrees equals pi over 6. We have to know that. So the sine of pi over 6, we go to pi over 6 on the unit circle. We look at the y value. It's equal to 1/2. This unit is the opposite. So I'm just giving you an example of showing you how it is the opposite. We're taking the inverse of a side, and that equals an angle. And that's what this statement right here says. You can only take sine, cosine, etc. of an angle, and that equals your SOHCAHTOA, or the inverse, or the arc sine, arc cosine. Last unit, you have to remember everything. Nothing that we've done all year goes away. It just keeps adding to. So when it says arc sine or arc cosine, you have to know that's the inverse sine or inverse cosine of a side, and that's going to equal the angle. Okay, so we have this notation, and then we also have the arc sine and arc cosine like we did in the last unit. Now, the directions will ask you to find the principal value. Principal value right there is going to tell you that it needs to be a function. The title of this section is functions. Trig functions. So it must be a function. When we find the principal value, that makes it a function. We had restrictions for the arc sine and arc cosine graph. Those restrictions are going to carry over into this unit. Question?
So to find like the inverse of sine, for example, would it help to do sine first for the angle?
No, because you don't know what it is. Okay? Because you won't have any idea. That's what you're trying to find. So you're not going to be able to put it in. If you're able to put it in, then you know the answer.
Yeah.
So no, that won't work. All right? Domain and ranges are restricted. That goes back to the last unit. When we graphed, we restricted the domain and range of sine and cosine. Now, The domain is restricted for all of them. All we graphed were inverse sine and inverse cosine, but they all have restrictions, and we'll talk about that in a second, right here, okay? So here are the restrictions. Inverse trig functions have restrictions because if you flip all the x's and the y's and you graph it, no longer becomes a function necessarily, and we need it to be a function. So these are the restrictions that you have to memorize and remember. The inverse sine, because there's two quadrants where sine is positive and two where it's negative. So back to that example a second ago, the inverse sine of 1/2, if we look at our unit circle, y is equal to 1/2 right here, and y is equal to 1/2 right here. There's two places where it's 1/2. So how do we know the answer? Well, we have these restrictions that make it a function. So when you are finding the inverse sine of something, you look for the angle that's either in quadrant 1 or 4, because it's going to ask you for the principal value. That word right there is important. Later on when we get into unit 6, we're just going to ask you for all the values. We're not going to specify to principal value. But right now it's principal value. Cosine can only be in 1 and 2. Inverse tangent, 1 and 4. So those are restrictions that you have to memorize and know. One of these is positive, one is negative. The sides are positive in quadrant 1 for sine, the opposite over adjacent. Opposite over hypotenuse. Opposite over hypotenuse is negative in quadrant 4. X and y, y is negative. Cosine, inverse cosine is positive. Adjacent over hypotenuse in quadrant 1. Adjacent over hypotenuse is negative in quadrant 2. And then tangent, positive 1, 1, and negative in 4. Signs are the same. Signs are opposite. So again, those are the restrictions that we use in order to make these a function and to find the principal value. As for principal value, you have to use restrictions. So if you look at that little x and y coordinate plane right there, we can write this in if that's helpful for you to see it written in a little bit different way. So those statements we just wrote are exactly the same as this, just a different way of looking at it. Do you want to look at it in the quadrants, or do you want to say what quadrants it is? It is the exact same information, just portrayed in two different ways. Inverse sine, 1 and 4. Inverse cosine, 1 and 2. Inverse tangent, 1 and 4. Okay, so remember, it's the inverse of a number. If that number is positive, we look in quadrant 1 for all of them. For inverse sine and tangent, if we're taking the inverse sine or tangent of a negative number, we look in quadrant 4. If we're looking for the inverse cosine of a number and that number is negative, we look in quadrant 2. Quadrant 3 is off limits for inverses. Now, this does not mean quadrant 3 has gone away from your life forever, okay? Quadrant 3 still exists. We just can't go through or into quadrant 3 when we're doing the inverse. If I asked you for the sine of 7 pi over 6, you cannot tell me now that that's undefined. Sine of 7 pi over 6, we can still find. We go to our unit circle, we go to 7 pi over 6, and we look at sine. That is equal to negative 1/2. That has not changed. This is not an inverse, okay? It is not an inverse. Quadrant 3 still exists for sine, cosine, tangent, secant, cosecant, but we just can't go into it for inverses only. So don't think everything we've done before is wrong and we're changing it. We're not changing anything. We're just adding to what we've done before. All right, so now using that information, let's work some of these problems. But before we do that, let's look at these top two expressions. So root 2 over 2. That is just the rationalized form of 1 over root 2. We don't care if you rationalize or not, but you have to recognize, I've said that all year long, you have to recognize whether something's rationalized or unrationalized. Root 3 over 3, if we follow the same pattern, if root 2 over 2 is 1 over root 2, then root 3 over 3 is 1 over root 3. If we were to rationalize, we would get that. So those numbers will come up. You'll see both of those numbers. if you write that, if that's an answer, I don't care which one, they're completely equal. One is not more simplified. Rationalizing doesn't mean simplifying. Those two aren't the same words. It's just a different form. It's like 1/2 versus 0.5, a fraction versus a decimal, rationalized versus unrationalized. Same thing. All right, so find the exact principal value of each expression in radians. If it's defined. If it's not defined, undefined, not defined, either one of those would be fine. We don't want to say no solution, because no solution means we were solving, and there's no equal sign, so no solution is not something we want to write. We can say undefined or not defined. Okay, use those words. Don't make up your own words. Use either undefined, and I don't care if you abbreviate or not defined. Don't say no solution. There's no equal sign, so there's no solutions to find here. All right, the inverse sign of 1/2. Now, some of you can look at that and you might know what to do. I like to show a little bit of work. It's not necessary, but what I do is, okay, so I think about my restrictions. Sign can only be in 1 and 4, so I mark those out. And then I pick, okay, the inverse sign of a positive number. So remember, these are the sides, the opposite over hypotenuse. That's going to be in quadrant 1. So really what I'm looking for is where is y equal to 1/2 in the 2 quadrants that I can be in. I can't ever be in 3, and the restrictions tell me that inverse sign has to be in 1 and 4. So I go to my unit circle. I'm looking in quadrant 1, and I look for where does y equal 1/2, and that's going to be at pi over 6. So there's your answer. Pi over 6. Yes?
How did you know it was quadrant 1 and not quadrant 4?
Well, so what do we know about quadrant 4? Inverse sign of a number is negative. So is 1/2 positive or negative? And the other way I know, so this is opposite over hypotenuse. In which of those quadrants is opposite going to be positive? In quadrant 1. Okay. All right, the inverse cosine of 2. So I know I have to be in either quadrants 1 or 2 because of my restrictions. Cosine, the sides are positive. Adjacent over hypotenuse is positive. Adjacent over hypotenuse is negative. Okay, so positive here, negative here. So we know we're in quadrant 1 because 2 is positive. So we look at our unit circle. Where is x equal to 2? Well, there's nowhere it's equal to 2. So that means 2 things. Either we have to draw a triangle because it's not on the unit circle, or it's not defined. Those are 2 options. So if we try to draw that triangle in quadrant 1, here's our angle that we're looking for. Adjacent is 2, hypotenuse is 1. Okay, well, where did that 1 come from? How do I make 2 a fraction? You can make any number. 2 is a rational number. If something is rational, we can turn that into 2. Think about slope. If the slope is 2 and you need rise over run, what do? You go up 2 and over 1. Same thing here. Can my hypotenuse be 1 with an adjacent side of 2? No, because the hypotenuse has to be the biggest number because it's across from the 90-degree angle. So this one is not defined or undefined. Goes back to unit 1. We talked about sine and cosine has to be between -1 and 1. And that's solely because opposite over hypotenuse, adjacent over hypotenuse, the hypotenuse is always the bigger number. So the inverse sine and inverse cosine of a side will never be bigger than 1 or smaller than -1. It will be somewhere in between. And if it's not, then it's no solution. Or, sorry, not no solution, not defined. All right, inverse tangent. Again, we just look at our restrictions. We can be in 1 or 4. Just got to know and memorize those restrictions. Negative, that's going to be down here in quadrant 4. So we've got to look for, tangent is opposite over adjacent, but we're on the unit circle. So that's y over we need to look for where does y over x equal negative 1. So we're down in quadrant 4. Y over x, y over x, y over x. Numbers are the same. Whenever you get a 1, that means the numbers are the same in the numerator and the denominator. So right here. Now, going back to that little x and y axis, it said we cannot go through or into quadrant 3. So if I start here and I go to 7 pi over 4, I've broken my rules. I cannot go through quadrant 3. So 7 pi over 4 is not the answer. You have to go from 0 and go down to negative pi over 4. 7 pi over 4 is not the principal value. Negative pi over 4 is the principal value. And these will always, always, always say principal value. Later on, when we do Unit 6 and we're finding all the solutions, that's going to be different. Doesn't matter. Doesn't ask for principal value. Principal value means it's going to be a function. In order to be a function, we have to have restrictions, and our restrictions state for the inverse we can't go into or go through quadrant 3. Therefore, on our unit circle, 3 pi over 2 will never be an answer. It'll be negative pi over 2. 5 pi over 3 will never be an answer, negative pi over 3. 7 pi over 4, not an answer, negative pi over 4. 11 pi over 6, not an answer, negative pi over 6. 2 pi, not an answer. It'll just be 0. You will not have multiple answers. Unit 1, we could have multiple answers. Here, we will not have multiple answers, and that's because of the restrictions. All right, next one. Inverse tangent of root 3 over 3. So, restrictions. We can be in 1 or 4. Because it's positive, we're in 1. So, root 3. There's only, when we look at our unit circle, we don't have a root 3 over 3. But remember, tangent is y over x. So we want to know where is y divided by x equal to root 3 over 3. Or we just started the lesson with root 3 over 3 is just the rationalized version of 1 over root 3. So if the better you can be about knowing those are exactly the same, the easier it's going to be on you. Okay, it's going to be much easier, and you're not going to say not defined and get those wrong. Root 3 over 3 equals 1 over root 3. Know those and use them interchangeably. All right, so the only two places on our unit circle where root 3 is even involved is at pi over 6. We have the point root 3 over 2 1/2. And at pi over 3, we have the point 1/2 root 3 over 2. I just got that straight off the unit circle. So if you look at your unit circle, that's the only place where a root 3 even pops up. Root 2 has nothing to do with this problem. So we just have to figure out where is y divided by x equal to either one of these. Okay, so y, I can't divide fractions, so I multiply by the reciprocal. 2 divided by 2 is 1. And there's your winner. Y divided by x at pi over 6 equals 1 over root 3. So there's your answer, pi over 6. Inverse cosine of negative 1/2. So the inverse cosine has restrictions. We can be in either 1 or 2. Because it's negative, we're going to end up in quadrant 2. So we're looking for where does x equal negative 1/2 in quadrant 2. We go to quadrant 2, we look for the x equals negative 1/2. There's your answer, 2 pi over 3. Now, I am showing a lot of work on these. This is not necessary to show all this work. The answer, your unit circle, is what's going to give you these answers. You do not have to show all the work I'm doing. I'm just showing you so that you can understand where the answers are coming from. If I just wrote down numbers, there'd be no way for you to know where it comes from. All right, inverse sine can be in 1 or 4. I can tell you that most people who do this don't make those silly mistakes of trying to write an answer of 3 pi over 2, 5 pi over 3, 7 pi over 4. Okay, so if you do this, it helps keep you out of the quadrants that you don't need to be in. But I would never grade this. This would just be something for you to use. So we're looking for where does y equal -1 in quadrants 1 or 4. So what would the answer to that one be? Good, -pi/2. It is not 3 pi/2 because 3 pi/2 would take us into and through quadrant 3, and we cannot go into or through quadrant 3 for inverses. Okay, we cannot go into or through. We have to start at standard position and go down, which would be in a negative direction. Questions on those? 6. All right, so now we have some double ones. Now, inverse sine and cosine. These will never both be inverses or both be sines or cosines. We can't do that. Okay, it's not possible to do that. Maybe later on in calculus you can do that, but right now, one will be an inverse and one will be a regular trig function. So we start from the inside out. So ignore this inverse sine. Cosine of -pi/6. We're back to unit 1. We just look at our unit circle and we evaluate cosine of -pi/6. Exact same thing you did in unit 1. You go to the unit circle, go to -pi/6, which is right here. Sine, is it sine? Cosine, thank you, is √3/2. So this is equal to √3/2. Then we're going to take the inverse sine of √3/2. So now we're back to a problem like the first 6 that we just did. We have restrictions. We can be in 1 or 4 because this is a positive number. That is quadrant 1. So we're looking for where is y equal to √3/2 because it's sine. And that's going to be at pi/3. Again, the answer, it'll always tell you to answer in radians. So do not put degrees down. The directions will always say to answer in radians. So be sure you do that on these non-calculator problems. All right, now this one we have the opposite. The tangents, the regular trig functions on the outside and the inverses on the inside. So we ignore that tangent. This is going to give us some angle. Maybe we figure out what that angle is, maybe not. If 1/5 was on the unit circle, we could figure out exactly what that angle is. But since it's not on the unit circle, we've just got to put it in the correct place. So inverse sine can be in 1 or 4. This is kind of like that inverse cosine of 2. It's either not defined or we have to draw a triangle. Because opposite over hypotenuse, hypotenuse can be 5, that can be done. It's not going to be undefined. So we draw our triangle with our angle in quadrant 1. Opposite is 1, hypotenuse is 5. Because the inverse sine of 1/5 is going to be equal to some angle. The inverse sine of 1/5 equals an angle. And it's the inverse sine of opposite over hypotenuse is going to give us an angle. So the opposite of that angle is 1. The hypotenuse of that angle is 5. Then we have to find the rest of our triangle. So it's just a right triangle. 25 equals 1 plus x squared, a squared, b squared, whatever letter you like. 24 equals x squared. When I take the square root, I get plus or minus 2 √6 equals x. I have to pick, do I use the positive or do I use the negative? Since I'm in quadrant 1, this is 2 √6. Now I need to find the tangent of this angle. This produced that angle. Something, doesn't matter what it is. It's in quadrant 1. That's all that matters is we know where it is. So now the tangent of an angle TOA equals opposite over adjacent. So the opposite of that angle is 1. The adjacent is 2 root 6. Or if you don't like those radicals in the denominator and you'd rather rationalize, root 6 over 12. If you want to rationalize it. You do not have to rationalize ever. You can. You have to recognize it, but you don't have to write it. 1 over 2 root 6 or root 6 over 12 is exactly the same. I do not care which way you write it. Either way is fine. All right, the inverse tangent of 2 times the sine of pi over 3. Ignore that inverse tangent. We need to find 2 times whatever the sine of pi over 3 is. Back to unit 1. Pi over 3, sine is the y value. Root 3 over 2. When we multiply that, the 2's cancel, and we get the inverse tangent of root 3. So now we're back to the problems, the first 6 problems that we did. Inverse tangent can be in 1 or 4. Because it's positive, we're looking in quadrant 1. If that was negative root 3, we'd look in quadrant 4. That's the only thing that would change. So, just like the problem we did a second ago, you might remember and say, oh, it's just the other one, which is true, but if you don't know what I'm talking about, then we know at pi over 6, the point is root 3 over 2, 1/2. At pi over 3, our point is 1/2. Root 3 over 2. Tangent is still y over x. 1/2, we can't divide fractions, so we multiply by the reciprocal. That equals 1 over root 3, or root 3 over 3. But we need a root 3. That does not match, so that's not the answer, so it's probably this one, but we want to make sure. Root 3 over 2 times the reciprocal of x, 2 over 1. 2's cancel. We get root 3. So at pi over 3, y divided by x equals root 3. So therefore, pi over 3 is your answer. Questions? All right, and then the last 3 are just using your calculator, and these are pretty self-explanatory. In your calculator, now, it does have to tell you in the directions. Unit 1, you had to know, because it was either a sine of 3 or the sine of 3 degrees, and you had to know that. But the inverse is a side, so you can only take the inverse of a side. A side is not degrees or radians ever. It's that y-axis from what we just did in Unit 2, graphing. Therefore, the directions have to tell you degrees or radians. These directions tell us radians, so all that means is our calculator needs to be in radian mode, which, when we clear it, it defaults to radian mode. And so then we just type in the inverse tangent. So second tangent, negative 2.9. And there's your answer. Round to the thousands, negative 1.239. That would be rounding to the thousandths. You always round to the thousandths when necessary. It is necessary when we ask for how many years. What's the time? If I ask for how many rabbits, you don't round. You truncate. You ignore the decimal. If I say in what year, 2003, you truncate. You ignore the decimal. But if it's anything else, seconds, times, hours, how many years, is different than in what year. Inverse sine, 0.75. So this would be necessary to round, 0.848. Second cosine, 0.058. 1.513. So those are easy. The ones tomorrow, you have to think a little bit more. It's not quite as easy to plug them in.